project context challenge was that there's a lot of litter, like 50 million kilos a year in the Netherlands only, and we were trying to chat or to, ik weet niet het Engelse woord, aan te pakken. Solve. Yeah. To solve the environment challenge, to pick that up and bring it to a bin or another place that can be recycled. And you need like a drone that you can manually fly and a waste or AI that you can see the waste and see what it is, so you can collect it and put it in the right bins. And we need a gripper that can pick it up and drop it. The project objective: design and build a drone system with vision, capabilities to detect, pick, and label litter. Canned plastic bottles, beer bottles, to the different sorting place. Alright, so the methodology followed, as the previous guy mentioned, is the lead model. So we basically start with brainstorming, coming up with the ideas, and then we basically plan, and then to test. Based on the results, we make sure that we come up with all the requirements. Right, so the main requirements, as my previous colleague mentioned. So we have three main litter types of waste. We have the glass bottle, the metal can, and the plastic bottle. We have to be able to identify first those three, then after the cart or the gripping mechanism should be able to come and pick it up, and then after it, the pilot should be able to fly and deliver it to the sorting station. The flying is manual, so no AI or autonomous driving, but the AI is only for the detection part.
Okay, so the technical challenges, we've had plenty of those. We have electronics, so we need to ensure that everything is stable, no shortages, or cables need to be well ordered, because else it gets a bit of a mess. I think we did pretty well in that part, considering. We also have the PI camera via Wi-Fi or Bluetooth. I think we use Wi-Fi now, correct? Yes. So that sends the footage to the laptop, but we'll get into that further in a minute. With Hardware, we of course had to mount everything on it. So as you can see, we had to use as many just screw holes as we could, because it's way more secure. At some places we used double-sided tape, also because some last-minute design changes required those. Also, like lightweight, we had to keep that in mind. Software, we needed real-time object detection, meaning we needed the camera and the footage, and of course needs to be in the algorithm to actually detect the litter. The design options, we have the vision setup. We have option A with the ESP32 cam, lightweight, had limited performance, or the Raspberry Pi. It's better quality, a bit bigger. We actually made a nice little mount for that here, so it even can have a cap on top, so it can be protected. It's also, of course, the option that we eventually went with, just because of the higher quality, and the ESP32 just didn't really cut it. We got the cart design. It has come a long way. We have motor-driven wheels. They are very small, DC driven. They have an internal gearbox, so they are quite strong. Not super fast, but just fast enough for the scope of this project. And it's controlled via the Arduino Bluetooth link, a bit like Team 3 had. That way we can easily control it. We tried to do it on the controller of the drone itself, only we had some technical difficulties that the servo and the motors wouldn't turn off and it would consume a lot of power. That's also how the first connector piece of our pla got a bit hollowed out because it was kept turning while it got stuck. So we had to make a new connector piece for that. It's kind of almost became the end of us, but luckily we had a spare. And of course, prioritize maneuverability and payload stability. With the drone and the load, there's quite, as you might be able to see, if the glass closed, the load will be a bit on the left. So we try to put as much of the heavy electronics on the right side, that when we actually have the load, that is a bit more stable. So unloaded, it would be a bit unstable to the right, and loaded, it would be a bit unstable to the left, but we try to make do with what we had.
For the design sessions, we used a Raspberry Pi plus PC setup with reliable YOLO P5 performance. The card is controlled by a Bluetooth connection by a phone. We have an app for it. So everything on the card, the gripper, the wheels, are all controlled with your phone. We printed the whole design, except for the electronics. But we first designed it on the computer and printed it part for part. The wheels are even printed. They are made from TPU. We'll talk about it more later. All parts are connected with screws, so we can easily swap it if we have an upgrade or something breaks. We mainly focus on strong design, so sometimes happens that the drone crashes. So it won't just break. Especially the wing parts are here, this front part, because it's pretty loose. The solution for it, we thought about printing some more sturdiness, just a ridge, so it won't bend inwards that easily.
Also, we have added the wheels with a lot of shock absorption, so that absorbs a lot of the shock, even if you have a bit of a rougher landing. Also, just because of the bit of flexibility, like little rocks in the way or something, they shouldn't be that big of a problem. So that way, it also doesn't really move a lot on the ground. So that also gets a bit nullified by the design of the wheel.
Implementation, I would say it's also covered, bit of the different steps that we do. Integration, I don't know if you want to mention something.
Yeah, we first thought about
We first talked about tank tracks because we were not sure what to do. We kind of quickly went to a car because we already know that the swinging of an arm was not possible. So we went to a car and then we talked about tank tracks because we thought, oh, tanks are robust, we can easily move. But with the links, it's quite difficult and they're quite expensive and quite hard to print. So we went to the wheels.
Very heavy also.
And very heavy, and we needed to stay light. So yeah, we quickly went to that, and we had I think we had motors on top, but we switched it down. We also need a chain, so we didn't want that, so we moved everything down.
Testing phase. With the testing of the wheels, we first had this design. It's the same design, but it was way thinner. It's really flexible. This was the TPU 90A material requested to us by Jochem. So a bit of a shout out to him. He gave us the idea to use this specific material. It's a quite new material from Bamboo Lab. It's really flexible. I'm going to pass it around. People can have a bit of a feel. It's, as you can probably tell, it's very shock absorbing, flexible. with the design of the little, let me see, spokes, I guess, they save a little bit more material with the actual thickness of the wheels, the radius, and it also adds to the flexibility, so it curves exactly how we want it. For instance, when we go over a bit of a bump, it will go over and it will bend. If the force is here, it will bend upwards, giving it a bit more. The flexibility. It gives it the flexibility in the side where we want it to, so it doesn't work against our movement. And then the vision system. If you remember.
You can see a bit of the similar results that we got, and then a bit of the schematics from the steps. The AI model to be able to train and perform in the best way. Kind of zoom out for the image. So finally the results. I think you can see we have a fully functioning car with the gripper mechanism, which we're gonna be showing you after. The AI is also working. We still have to attach the Raspberry Pi and send the footage, but we can also show you right now.
How much does the system weigh
In total,
without the drone?
we didn't weight it, but I think less
We
than
tested flying with glass bottle, with full water plastic bottle, and we were still able to fly without this very big disturbance. The only disturbance that we had is when you close the gripper, we were veering a bit to the left. But we tried to manage this with the battery pack, and also we placed the Raspberry Pi on the other side.
I would like to mention that your time is running up, so.
Yes. You can skip this part if it's better for the time.
It's up to you, you have a couple of minutes left.
Then I think it's better if we just ship this. One more thing that I do want to show is the coupling mechanism in collaboration with Team 3. It's a bit thick, it's made out of TPU as well. It's nice and flexible, easy to put over the grip, the mount, and that way you can easily put it on and it flies up.
Great. So now you're gonna showcase the gripper?
Yes.
Great. Already done.
And then it
I would
goes.
like to see it again.
I drop it
Yeah.
and I pull it back.
You crush it immediately.
Yes.
Perfect.
Better for
And
Oh,
this
you
is
can
your-
do this.
Okay.
With another bottle also.
Yeah, one moment. I just do it too quick.
Yes, I can also. This is with the plastic bottle.
Yes.
I can try.
So, put it in.
Yeah.
Nice.
Yes. And we
Great.
can drop
So
the
plastic also a one
and glass.
glass. That's yeah, that's fault. So, yeah,
Well, it's a
tell
bit
them as well.
hard for it.
This is another issue.
Let it go and try again.
And it's not hard back.
Another.
when you pick it up, it goes in.
If you think it's okay, we're gonna do final, so we're gonna place the bottle here, we start the car here, and then pick it up here. And then you have to lift your car.
I will start at 13. It.
Okay,
It's a bit lifted.
lift the car. Yeah, okay, so that's a failure. Okay, 2 points and 1 Oh yeah, okay, that's wait.
Go for the glass.
Okay, and with some iterations,
Yeah, it's good. It could,
Ja,
because if
dat
you
is-
just add a bit more force on
Yeah,
switch
yeah.
scoop,
Ja,
and
ja.
see, it really doesn't take
joke
much.
of
I
the
think
grappen
the
bij zo'n
just
video
because
dat
we
zie.
had the mounting,
Or is this
the
because of the
connector. I think-
oh,
I think it might be.
Hij staat
Yeah,
er
Because
nog
if you can feel if you want.
So I would like to answer
Zo
the
was het een beetje dik zo.
You can just feel it.
So what I would like to suggest, take a look if you can fix it for the competition later on the day. Yeah? Thank you very much.
Right. First of all, I would like to ask Pavel, do you have a question?
Only one of, it's not really a question, but if this is going to the nature, then I think you will need to improve the clearance between the ground and the frame.
Yeah, but that's a problem with all the systems as usually is.
Yeah,
There's
but
so
if-
much clearing.
if we
Fabian, laat
increase
even
the-
het team zelf antwoorden.
I think if we increase the clearance, then we will have a hard time picking again the glass bottles and maybe some heavier litter.
Right, okay. Thijs, laatste vraag. Last question?
Last question?
Yes, please.
Okay, it was a clear presentation. It was very good. I was wondering, you want to drive the car, so you have motors, for every wheel has a motor. Why would you need a motor? Because you have the drone, which could possibly drive the car by flying the drone.
Because if the propellers are turning, the bottles will just fly away. That was one of the main problems we encountered. So we chose to land it and let it drive on itself without using
Okay.
propellers.
Okay, that's clear. And also, I notice you have 4 wheels, and if you're turning, a couple of wheels are slipping, right?
Yeah, that I think comes from the amount of PWM I'm entering inside the motors, and the motors are a bit stronger because we have 4 of them. This could be changed via software.
Really?
And could
Because
be
if you
adapted.
have these 4 wheels and they are fixed, and you want to turn, there's some of the wheels have to slip. That's not possible by.
Yeah, for that we would need some kind of differential between the wheels, but that's a bit complex.
That's
to
too
put on
complex
the
for this. So what would be the other obvious solution to that?
Making steering mechanism.
It's also complex, of course.
Yeah.
Tank wheels maybe.
Sorry, tank
Tank
wheels.
I mean, it's practically the same.
By definition, they are slipping also.
I know the answer you're looking for. Can I answer?
No.
I suggest that you think about it during the judge
Yes.
moment. You can come back and discuss it. So thank you very much for now. Nice solution, and I would like to ask the audience to give a last applause to them.
Well done.
Okay, laatste team, team number 1, please.